Alright, time for another DraftPhysics.com video presentation. Debate physics also, and so I guess I should find the most recent video by Ian Gosling encouraging, because at least he's trying to deal with the dilemma that physics has in terms of the theoretical argument. So, I shall explain. Where they have a real problem, and they really aren't, no one's dealt with that problem in any rational way. So the argument is that gravity is a time-dependent force. That's my clear argument, all right? And it's made clear by these different things I have drawn over and over and over again in terms of experiments that demonstrate the fact, okay? And one of these experiments is just dropping things in gravity. And the idea there is that you have to drop something from 4 times the height to double its velocity. And so, from a crude distance perspective, people will say, well, this is a more distance, and so more distance equals more energy. So it acquired more energy because it fell more distance. And now the logic is that it's falling that distance at variable speeds. And the fact is, is that it's going to be about how much time it's in the gravity. It will decide how much energy it has. And so the first unit of time will be this, and this. This is the same. This event will be exactly the same as this event, all right, in terms of the first unit of distance. But this second event will take place in exactly the same amount of time, but it clearly won't be the same distance. It'll be a lot more distance, all right, but it's the same time. So in the experiment, what you end up with is yes, this takes 1 unit of time, so let's just say 1 second to do this, and it takes 2 seconds to go 4 times the distance, all right, so it's only 2 seconds, 2 units of time. And the fact is, we already know that it has 2 velocity. So the velocity will be twice the velocity landing here. And the truth is, it's going to be twice the weight. So these 2's are the real definition of what's going on. It's twice the energy. It's not 4 times the energy. Falling 4 times the distance doesn't give you 4 times the energy. Now, this is sort of proven, by the other example I gave, where you could just have a set distance going from the surface to the surface of the Earth. You could go 1 mile out, and if you give things an initial velocity, let's say one thing I just let it go from 1 mile high, and the other thing goes in with 500 miles an hour velocity. The thing I just let go might take 15 seconds to hit the ground, and the thing coming in at 500 miles an hour will take 1 second to hit the ground. And so in this circumstance, the thing going 500 miles an hour will end up, having a landing velocity of only 509.8 because it was only in the gravity 1 second. And the thing that started with no velocity will hit the ground with 150, because it had plenty of time to be pushed by the force to collect rain or to collect photons, however you want to think about it. So the simple argument is gravity completely duplicates exactly what light bulbs do, in terms of it's an inverse square law that decides the distribution of the force. So photons are ejected by light bulbs with the same squared rule that gravity affects us by, indicating that yes, it's just the opposite kind of effect. A light bulb you can think of as pushing, and you can think of the Earth as pulletons, but the fact is this really is just pushing. It's just that the Earth is producing less energy coming up, and therefore the energy pushing down is greater than the energy pushing up, and that differential creates gravity, and it takes time. So just like it takes time for you to get a suntan, if you just poofed, if there was a sun somewhere radiating, and I just make you bang, you exist. It's going to take time for you to get a suntan. You're not going to get tanned instantly. Each photon's going to have to hit you. Each one does their little job, and you have to it takes time to collect them. The same thing happens when you're being affected by a gravitational field. It takes time for little bits to hit you, and each one of them will come at its particular time. Every billionth of a second there'll be some amount hitting you, and you have to collect those before you can have something called weight. So your weight takes time to collect. Alright, so lots of these arguments have been made. So now he had an extensive conversation in his own chat, his own comment section about thin ice. And thin ice provides a simple enough analogy that, let's say there was ice and there was some thin patch. I'll just draw it like that. And then, hard ice. So you knew there was a thin patch of ice. And the simple argument is that I think, most people might have had the experience that if they can glide across that thin ice quickly, they won't fall in. But if they don't glide quickly and they stay on the surface of the ice for a longer period of time, that they will, in fact, their real weight, their real mass, will collect energy, and they'll collect enough energy to break the ice and fall through the ice. But you can make yourself lighter, you can weigh less by simply going faster across the weak ice. So you collect an insufficient amount of suntan or rain or whatever you want to call it in your mass bucket, and you just don't have sufficient weight to break the ice. Now what he is now suggesting is it's so preposterously silly that it's not really theoretical physics, because it's just it's so dumb. So anyway, so what he's basically saying is that, okay, let's say we have that same scenario. We have a patch of thin ice, maybe dotted lines, and so he's saying now that somehow I would agree to some notion that, okay, I could stand on the ice, all right, I'll just stand on it, and I'll just let myself weigh what I weigh, and I'll break through the ice. And then he's suggesting that somehow I'm pointing out that somehow if I ran around in circles really fast over the thin ice, that is, the thin ice is there and I just decided to run around in circles, that somehow I'm going to weigh less. No, that's not my argument. Theoretically, if I'm covering more space, all the better, but it's not going to be enough to keep me from falling through the ice. And especially if I just sat, on a whatever those little things that have wheels on them, a little coaster, and I just spun around in circles right in this spot. Somehow he's thinking that I'm saying if I spun around in circles that somehow I'm collecting less gravity. That somehow I'd get less wet in the rain. If I go out in the rain and I run around in circles, I'll get less wet. Or that if I spun really fast, I'd get less wet. No, that's not my argument. I'm saying that in every single case, there's no case you can describe in our physical reality, no experiment, no circumstance, where gravity is causing friction, or where gravity is in control of a circumstance, where I can't demonstrate that it's all about time. Just figure out how much time the thing was in the gravity, and I can tell you how much force was applied in the system. Because that's all that matters, is how much time is the force hitting you, and then how much time are you in contact with some other mechanism that has to absorb that force, where you're not free falling. If you're free falling, it's really simple. If I give you extra velocity, okay, you're going 500 miles an hour, and I put you through 1 second, okay, of distance at 500 miles an hour with gravity pushing you, it's not going to push you very much. It's not going to add much to your velocity, because you're not going to be in it very long. So how else? What else can I say? So it's just, he's wasting time, 6 minutes and 36 seconds, describing something that's just ludicrous. that somehow he's describing an experiment where clearly you're in the gravity the same amount of time. If you're spinning around in circles, you're in the gravity the same amount of time. You haven't changed how much gravity you're exposed to while you're over the surface. So it doesn't get to this point of your obligation is to prove where time doesn't work and distance does. So the distance gives you a right answer exclusive of time giving you the right answer. You're trying to prove that distance is the source. And to do that, you have to find some circumstance where time isn't, where time doesn't work. And clearly, this circumstance is not changing how much time you're in the gravity. It's not changing how suntanned you're getting. Spinning in a circle won't get you less suntan. Running around in a circle won't get you less suntanned. So it's just a really nonsensical argument, and it doesn't address any of what I've argued or said. So none of my examples will he use and show how any of those examples where I provided incorrect information or said something that isn't true to the actual reality. Like, for example, coming into Earth's gravity at 500 miles an hour, and how the gravity will give you very little energy. So even though you'll travel through a lot of Earth gravity, you'll gain no velocity from it. Barely any. A small, tiny percentage of your impact velocity will be because of the Earth's gravity. Tiny percentage. Where, if you come in slowly, a huge percentage of your velocity will be because of gravity. Alright. Did I have to say more? I mean, I really don't have to go back to, I have drawn it so many times. I mean, the flyby argument is just so obvious. I'm going to fly by the moon. I'm going to shoot for, I'm going to Pluto. But I'm going to fly by the moon as I'm going to Pluto. And, how much the moon is going to bend my trajectory is completely determined by how long I'm exposed to that lunar gravity. How close I am, how strong the differential is, and how long I'm in that differential. And that's all to decide. I go by the moon slow, I'll be bent a lot. I go by the moon fast, I'll be bent very little, because there's very little time for the differential to work on me. Very little time for the extra photons to tan this side of me, so to speak. So I think it's good that he's acknowledging that his physics has a problem, because if it is true that gravity is a time-dependent force, then you really can't make logical sense out of any kind of notion that 4 times the distance is 4 times the energy. Because if you're going twice as fast, you're only using 2 units of time, then as a time-dependent force, well, then you can only have 2 units of energy. And clearly, the fact is the velocity number confirms the time number. The fact is it's 2 units of time, and it's 2 units of velocity, and in fact it's 2 units of weight, and that's all you've gained. There is no kinetic energy quadratic increase in your energy. Alright, so I guess I'll play the end of his video, but it was just such a alright, so a little bit of an OBS crash, but anyway, so we'll play the end of this video, and yeah, it's just nonsense. So he's just basically arguing for putting something on a scale and basically saying, look, you can just think of the ice skater spinning in a circle, spinning. That somehow spinning makes you weigh less. Of course it doesn't.
Would it not be true, Gary, still, the faster the object moves, the less weight per unit distance would be registered?
It's true that over this little narrow circle that you're distributing the weight over a larger area. So theoretically, if this was 10 feet around and the difference was you standing in 1 square foot and this you're applying the pressure over 10 square feet, that the likelihood is you're not going to fall through the ice. But the fact is you still weigh Okay, you're collected the same gravitational energy and you're putting the same energy into the ice. It's just you're putting it over a smaller area. So if you did something to make it the same area, so in the example he's providing, the same area is the platform of the scale. So he's basically trying to argue that somewhere in my theory I'm saying that if I put the weight on here and then I move across this scale, that somehow I'll weigh less. And I can't weigh less as long as I'm in contact with the scale. Doesn't matter whether I move the weight around, I can do anything I want to the weight, but if the weight's still on the platform, I'm going to weigh the same. So I could have like a magnet, I could move it underneath the scale, I could move the magnet all the way around. Wouldn't make any difference. It's still going to weigh exactly the same. Moving it on this platform can't change how much it weighs, because it's still affected by the same amount of force hitting it, and it has the same contact with the scale. The point is you have to reduce the contact. So I gave the simple analogy, right, that we could just make this a road, right? I could put a road on this side of the scale and a road on this side of the scale, and I think all of you could understand that the faster I roll something across the scale, the less it's going to push down on the scale, the less weight will be registered by the scale. And that theoretically I go almost fast enough where it doesn't weigh anything at all. Come on. It's a time-dependent force. It takes time for you to weigh something.
Registered on the scale. I don't know whether you have any theoretical objections to that.
Yeah, I think it's just nonsense. Talking about spinning something on the top of a scale and saying that somehow I implied that that would weigh less. I didn't imply it. I didn't say it. It's not an argument I've made. And again, you've just totally evaded every single one of the diagrams I have drawn. You won't refute them or dispute them. And instead, you do this straw man crap where you invent something I didn't say and pretend to debunk it.
Because what I'm thinking is I could do this experiment.
I'd rather you redo the clay experiments, the dropping things on clay. I'd like to see it.
I could have some kind of, I'm thinking of a power drill, say, with an arm,
I mean, he called it a proof and was very proud of the video when it showed him being right. When he had the wrong measurements. And then he didn't video it and didn't show it when he did it the right way, and it came out my way.
A substantial weight that would roll on a bearing, and it would be pivoted so that...
Yeah, so it would be in the gravitational rain exactly the same amount of time. It would get just as wet, and going around in circles isn't going to let you get less wet in the rain. It's not going to work. And it's got exactly the same amount of contact with the platform of the scale. So what have you changed? Oh, that's right, nothing.
Independent of where the drill was pushing or pulling, the weight remained the same. But it would revolve the weight around the periphery of the scale pan. And we could...
Yes, and so it would be on the scale pan exactly the same amount of time as if it just stood there.
Go at different velocities. It will be covering a unit distance.
Your obligation is to show something where the difference in time doesn't make a difference in force. That's your obligation. So showing things where things are in the gravity at the same time isn't going to work for your side.
In different times, therefore should register a different weight.
How can it possibly register a different weight when it's on the same scale, pushing on the same scale exactly the same amount because it's being pushed by gravity that it's still in? The same amount of rain is hitting it, it's just as wet, it weighs just as much. It's collected just as much force and it's distributed just as much force to the surface. You haven't evaded the surface.
Are you with me?
No.
What would be your objections to that?
It's ludicrous and it's silly and it's a straw man. It has nothing to do with what your obligation is, which is to show something where different amounts of time create the same amount of gravity.
Experiment. Gary, let me know.
Okay, there's that. Do you know now? Let's see, I don't know if there's any comments. Yeah, see, no one's ever going to comment on any of his videos because they're never going to explain to him, Ian, just let this go. You're not going to win this argument. But he's got 8 thumbs up, I mean, which is hilarious. Oh, it's 5, okay. For just a junk video. I mean, not only, it's just a straw man to say that anywhere I argued or implied any of this nonsense. You know. And it has nothing to do with anything I've drawn or illustrated, and it doesn't get to the point, which is you have to show where any analysis of any system of gravity where time gives you the wrong answer. Just measuring how much time something is in a force differential, how long a sailboat is in the wind, will tell you how much energy it collected. How much time something is in sunlight will tell you how much radiation it is absorbed. This is the argument, that it is a real force and you collect it based on how much time you are exposed to the force. Yeah, I can't say it any clearer than that, I don't think. So we'll call that a video, and such and so forth. And what? Yeah. So I guess it's better than nothing. He's trying to argue theory. He's just not nearly. He just doesn't. He just doesn't have enough foundational physics knowledge to do it reasonably.